Hello, and welcome to the next session in my webinar series on C++ Standard Template Library by Example. Today we're going to change gears a little bit, and instead of looking at specific C++ STL features or containers or algorithms and so on, we're going to show an example that illustrates how to apply various C++ STL algorithms and various features in the context of a program that will look for conflicts in meeting schedules. And it'll also go ahead and print out a schedule that's sorted by the date and time of the meetings. So without any further ado, let me share my screen and we'll start taking a look at the code. So as always, you can find the source code in my GitHub repository, and this is in the C++ meeting-scheduler subfolder, and all the files we're about to look at can be found there. So now let's go ahead and move over to my CLion IDE, and you'll see this is the main.cpp file. We're going to spend a bunch of time in this in a second. But before we do anything looking at the code, I actually want to show you how the program works, and then we'll take a look at the code because I think it'll make more sense. So let me go ahead and open up my shell here, and I'm going to show you what's in the file. So what's actually in the file, this is the file itself, and you can see it has a list of classes. Those are our meetings that we're going to schedule, my classes I teach. And we're going to have the class number like CS101 or CS251. We have the days of the week when they're taught, which would be M for Monday and W for Wednesday and F for Friday and so on. And then we're also going to have the times when they start. And the times are going to be given in 24-hour time. So for example, CS101 is taught on Wednesdays from 17:30 to 20:30, which is 5:30 to 8:30. And likewise, CS242 is taught a couple of different times. And what we're going to do here is we're going to run a program that's going to check to see if there's any conflicts in the schedule. And a conflict occurs if you have two classes that are taught on the same day at overlapping times. So let's assume for whatever reason that we only have one classroom, and so we have to be careful how we schedule things. So let me go ahead and run the program. I'm going to run this program, which has all the various rows with each of the classes and their days and times, and I'm going to go ahead and pipe it through the xargs program. And xargs is a program that's going to take the argument here, which is the program that we're going to run, the meeting scheduler program, and it's going to convert the contents of the file into argv argc command line parameters. And that's what the program's actually going to use in order to do its processing. So let's go ahead and run it. And you can see here that we've got a couple of conflicts. CS251 and CS242 have overlapping times on Tuesdays. And we also see CS242 and CS281 also have conflicting overlapping times also on Tuesday. So these are examples of conflicts, and then what happens down below is it goes ahead and it prints a schedule from Monday through, in this case, Thursday, with all the times of each class starting and finishing. Okay, so that's what the program is going to do. So let's go ahead and return back to the code and talk about how it works. So here's the main function. As it can see in the comments, it reads a list of meeting times and dates that are provided as argc argv command line parameters to the program, as we just saw. And then it goes ahead and it detects and prints any conflicts, situations where there's overlaps, as we just saw. And finally, it's going to write the sorted schedule to the output. All right, so let's go ahead and see how we do this. And I'll walk through the whole program at a high level first, and then we'll dive down into each of the parts. We're going to store the actual meeting schedule in a vector. So it's going to be a vector of meetings. And we'll talk more about what a meeting is in a second, but for right now, just to keep things moving, a meeting is a struct that's going to keep track of the name of the meeting, the day of the meeting, and the start time and finish time of the meeting. And we'll come back and look at that in a second. So then what we're going to do is we're going to take the contents we get as argc argv parameters to main, and we're going to use a really cool custom iterator adapter that I wrote called an argv iterator. And what argv iterator does is it's going to treat argc argv as input to be converted into an iterator format. And by doing this, we're going to be able to read the command line parameters that are passed in as argv argc and then use them in the standard copy algorithm. So we're going to be able to use the argv iterator adapter, much like we've used stuff like iStream iterator adapter in previous examples. And we're going to be able to read from the command lines and then take the contents that come in the argv parameters, convert them into meeting objects, and then insert them at the end of the schedule. So you can see here we're going to use back inserter as the output iterator to adapt the schedule vector into something that can be treated as an output iterator. So I'll take a closer look at argv iterator adapter in just a second, but this is kind of at a high level. We're reading from the command line parameters and sticking things at the end of the vector. And notice the cool use of STL adapters to make all this very seamless and allow us to reuse code like the copy algorithm. After we've done this, we go ahead and we sort the contents of the vector from beginning to end. That's just a good old sort algorithm. I perhaps could have stored the meeting contents into a set, and then I wouldn't have had to have sorted it, but this works just as well. The next thing I do, and this is really the fun part of the program when we get to this a little bit later, I call a helper method called check for conflicts, and I give it the beginning of the schedule and the end of the schedule. Now keep in mind the schedule is now sorted, and it's sorted in such a way where it'll be sorted so that each day will be sorted by Monday, Tuesday, Wednesday, Thursday, Friday, and so on. And then within each day, it'll be sorted using the less than operation on a meeting object, which is used to make sure that things show up in the right order when you sort them. We'll talk more about that in a second. So then I go ahead and call check for conflicts on the sorted schedule, and it will go through and use a couple of different techniques to find out where there are conflicts. And you'll see we're going to use two different approaches. One is based on the C++ adjacent find algorithm, and the other is based on the C++ STL transform algorithm. And we'll compare the pros and cons of each approach shortly. When we're all done, we will have printed out any conflicts if they exist, and then we're just going to dump the schedule from beginning to end in sorted order, and we'll use the cBegin and cEnd method on schedule, which return const iterators because we're just reading the elements. And then we're going to go ahead and use the OStream iterator adapter to write the output to the standard output. All right, so that's a high-level view of what's going on. Now let's kind of dive down into each of the piece parts. We'll start by taking a look at the argv iterator. I'm particularly proud of this clever little class because it's a great example of how you can use adapters to great effect with STL algorithms. So we take something that wasn't meant to be used with the copy algorithm, namely argv, argc, and we convert it into something that works quite nicely that way. So argv iterator is a template class that's parameterized by type T. In our case, we're going to be creating meeting objects out of the contents of argv and argc. And it inherits from iterator and in fact is a forward iterator. So that's the forward iterator tag. It'll only go in one direction from left to right. We have a default constructor that gives everybody either zeros or nulls. And I guess if I was really being smart, I would use null pointer. I can see the compiler is yelling at me to use null pointer because that's the C++ 11-ish way of doing things. So I will respect C++ 11-ish ways of doing things in this regard. Down here, I have the constructor that we're actually using along with the copy algorithm, and we give it argc and argv. Now, if you go take a look at the way it's called here, we pass argc minus 1. Argc is the count of the number of parameters that are passed on the command line. And we do this because, of course, we want to skip over the first parameter, which is the name of the program itself. So we don't need to include that. So we're going to be argc minus 1. And likewise, we're going to be argv plus 1, where argv is going to be the pointer to an array of strings. And we're going to skip over the first element because that's the name of the program. So we start out by incrementing argv and decrementing argc. And that's what we're passing into this constructor here. And then what we do is we stash those values away in local data members. So argc underscore gets set to argc, argv underscore gets set to argv, base argv gets set to argv and stays there, whereas we'll see that the argv underscore gets incremented, and it's going to get incremented by the count that's passed in here. And if you look at the main program, you can see the count is 4, and that's because if you go look at the input file, which, whoops, we had shown earlier here, the input file that we had 4 columns for each row. And these 4 columns, of course, are going to correspond to the state that we want to use to initialize our meeting object. So that's why we're going to skip over 4 every time we do an increment. So let's go ahead and see how the actual iterator works. I only implement a few of the iterator methods, just the ones I need to get the job done. I implement the not equal iterator, and that's used to see if we've reached the end. And we know we've reached the end when the argv underscore pointer is going to be equal to base argv plus argc. So that means we've gone through all the elements that we're iterating over. The dereference operation, which is what you use when you want to read the contents, that is going to simply take whatever argv points to, which remember that's a char star star, or it's an array of characters, and it goes ahead and it will convert that into an instance of whatever parameterized type has been given to the argv iterator template. Now, in our particular case, that's going to be the meeting. And in fact, if you go back here, you'll see that we expect there's a constructor for meeting that takes a char star star. And in fact, if we go over here and look at the constructor, we will see that there is indeed a constructor for meeting that takes a char star star. And we'll take a look at how that works in a second. All right, so then down here, we have the overloaded operator plus plus. This is the pre-increment version, and it will skip over the argv parameters by the increment designated in the constructor. In our case, it's 4, and that's because there's 4 columns per row that are used to initialize each meeting object, namely the title, the day of the week as a character, and then the start time and the finish time. All right, so that's basically what we got here. You can see just down there we have argc and underscore and argv underscore and base argv underscore and increment. So that's our very, very clever argv iterator, and I think that gets used to nice effect here to kind of make everything hold together in the context of STL and its algorithms. Let's now go ahead and take a look at the meeting class, or struct in this case. And this is basically the data structure we're going to use to store information about each meeting, including its title, its day of the week, and its start time and finish time. So to make this easy, we're going to have an enumerated type called day of week with a bunch of enumerated literals corresponding to each day. We have a little factory method that takes a character and returns the corresponding enumerated type. We have that constructor I just showed you that takes a char star star and will convert that into a meeting object. And we've got relational operators, the less than operator is used by the sort algorithm, and then the equality operator is used in a very, very clever way by the check for conflicts method, and we'll see how that gets used in a second. And then the other elements are just what you'd expect. They're the title, in other words, the name of the meeting, the day of the week, and the start time and the end time. And we're using the syntax here that says initialize this to its default value, so we don't have to remember to do it in the constructor. Let's now go ahead and take a look at the implementation of the meeting class. You can see here's the one that takes the char star star, so that's what gets called by the argv iterator. If you recall right here, operator dereference will go ahead and create this object using this constructor. And what it does is really quite cool. It takes argv and says argv sub 0 is the string that corresponds to the name of the meeting, which for example would be something like CS101 in our case. And then it takes in argv sub 1 and takes the character there, which is going, of course, to be the day of the week. And you can see here that that could be W or T or R for Thursday and W for Wednesday and so on. And then we go into the body of the constructor, and here we're going to convert the string parameters that come in from argv argc, which namely are things like 1730 and 1130 and 1430 and so on. We're going to convert those into the corresponding numbers. And the way we do that is by using a string stream. So we create a string stream A1, which is argv sub 2, and then we make a string stream A2, which is argv sub 3, and then we go ahead and use the extraction operator to go ahead and put the contents of the stream into the start time and into the finish time. So that's a little cleaner than using something like A to I, which is all full of weird problems if you give it the wrong kind of input. Okay, so that's the constructor that takes a char star star and converts that into a meeting. Down here we have the method that takes a character and converts it into the appropriate enumerated literal, does exactly what you think it does. It does a switch statement and then returns the right literal. Here is the operator equality, and this is used by the adjacent find algorithm and also by transform, depending on which version you use, in order to be able to detect overlaps in meeting times. And here's how it works. Let's give an example of a conflict that I showed you before. Here's CS242 and CS281. They both appear on Tuesday, and CS242 starts at 12:30 and goes to 14:30. CS281 starts at 1300 and goes to 14:30. And you can see here they both have the same day. The start time for CS242 is indeed less than the start time for CS281. However, the start time for CS281 is less than the finish time for CS242. So that's an indication that there's an overlap and a conflict. And so that will return true, even though they don't actually have exactly the same value. They have the overlap, and that's what makes them equal. And then there's some other checks we can do for other cases that are also indicia of overlaps. Down here is the less than operator. This, of course, is what's going to be used by the sort algorithm in order to be able to order the meetings in the correct order by day and by time within the day. So that goes ahead and does this. And then the last thing we have here is the insertion operation that takes the output of a meeting and writes it into the given O string. And again, it just formats it in a nice way. Okay, so that's the meeting class. Let's now go back to the main class, or the main method, and we'll find the last thing to talk about. And this is really the fun part, because this is what's going to show off some of these other cool STL algorithms that we've been talking about, and some that we will talk further about in later parts of the course. So the method is called check for conflicts. Just for generality, I made it be a generic method. So it's parameterized by the input iterator. And in this case, the input iterator is going to be the beginning of the schedule vector and the end of the schedule vector. So we're going to check for conflicts in our schedule. Now I've got two versions here. The first one, which I've got enabled at the moment, is going to check for conflicts using the adjacent find algorithm. And we've talked about adjacent find. The way it works is you give it a range from beginning to end of iterators, and it will return an iterator to the first element in that range where two adjacent elements have the same value. So of course, in this case, we're going to be using the equal operation on meeting to find out if there's conflicts. So we're basically doing this to check for conflicts. And here's how it works. We start out by making a kind of a temp iterator called iter, and we start at the beginning. We keep going while we haven't reached the end. And every time through this loop, we use adjacent find, starting at the current value of the iterator, which initially is at the beginning, and then going to the end. And we'll get back an updated iterator. Now, if that iterator equals end, it means there were no values in that range that were equal when they were adjacent. But if we do get a hit and it's not the end, we know we've found a conflict. So we print out conflict in big capital letters, and we say iter sub 0 and iter sub 1. And those are the two values that are adjacent to each other from the point of view of the iterator. And then in this case, we increment the iterator by 1 so we can skip over the one we just found the match on and then start comparing at the next element to see if there's a match there. So this could potentially iterate and find multiple matches, and that's why we use a loop. So that's one way to do things. Another way to do things is to use the transform algorithm. Now, we've talked a bit about transform before. Adjacent find is a non-mutating algorithm, so it doesn't make any changes to the underlying container that it's going to be iterating over. Transform, in contrast, is a mutating algorithm, except we're going to use it in such a way here where we don't actually mutate it, we just update it in place. And the reason I use transform is because I didn't actually have to write a loop. So you'll notice here I had to write a loop and call adjacent find multiple times. But transform doesn't require calling a loop. You can do this in a single in a single call. It's not they're both single pass because the other one is going to keep jumping. The adjacent find will keep jumping by the iterator returned, and you skip over everything else and start at the next iterator. But transform is cool because you can do it in one fell swoop without having to have a loop. So here's what we're going to do. We're going to start with the beginning of the iterator range going up to one less than the end. So let's say that there's, I don't know, 16 elements. So we're going to start with 0 up to 14, let's see, up to 15. Not the 15th not you know, sub 15, but the 15th element. We won't go to the very last one. And then we're going to start the second range for transform one past the beginning. And that, of course, will go up to the end. So we're basically going to have two ranges that are going to be offset by 1. And they're just going to march through here. And this binary function is going to be called at every step along the way in order to transform. And so let's go ahead and see what transform will do. But before I show you what we're going to be transforming via this binary function, let me show you what we're transforming into. We're actually transforming back into ourself. So we're doing this transformation, but we're actually not changing anything. We're just writing the value back to where it started from. And transform works perfectly fine like that. So here is the lambda function that we define, which is going to be using a decal type mechanism to deduce the actual type. In this case, it's the meeting type. And I probably could have put meeting in here because it's pretty clear that this is looking for meeting conflicts. But just for kicks, just because I like using decal type, I use decal type on star begin, and that will figure out the type of that, and that'll make that the parameter that's passed here for the lambda. And so I pass by reference to avoid having to do copies. And so what I've got here is basically meeting ref left-hand side, meeting ref right-hand side. And of course, what they're really going to be is they're going to actually be adjacent elements in the underlying container as I march from begin to begin plus 1. I march down through them in a pairwise fashion. So if it turns out that the left-hand side equals the right-hand side, in other words, if our equality operation on the meeting returns true, that means there was an overlap in the time, and of course that'll come out as a conflict. So we'll print the conflict. And then the last thing we do is we return the left-hand side just so it'll get updated in place. So two different ways of doing this checking. One of them uses adjacent find, which is honestly probably the right way to do it because transform, as we'll see in a second, is a bit overkill. But adjacent find requires us to use an explicit loop. Conversely, transform does not require an explicit loop. It does the looping internally, and we pass in a binary function. The downside is that it's probably doing more work than we really need because it's doing this right back to the vector, and we don't really need to do that. But the point is that STL gives us all kinds of opportunities to do cool things, and then we can decide what makes the most sense given our requirements and what we're trying to achieve. Okay, so that is the program that I wanted to show you today. I think it's really fun, and it's just a great example of all the interesting things you can do with STL and how very little code we actually had to write, and especially very little custom code we had to write. Let's assume that the VIterator is something we could reuse for other classes. So that was well invested time to make ourselves a generic VIterator. And that worked seamlessly with the copy algorithm. We used the back inserter, which is also another STL iterator adapter. We used the sort algorithm to sort the vector. We were able to use the adjacent find and or transform methods to do our thing. And so really the only thing that we wrote that was kind of custom for this application was the meeting struct that we had, which makes sense because we have to do some domain-centric programming, and that's what it was. But almost everything else just kind of came along for the ride. We wrote insertion and extraction operations, so we can use those things. That we used the string stream in order to be able to convert strings to numbers. So the real take-home point of all this is that STL makes it really easy to write reusable code. It makes it really easy to reuse existing STL code, and it makes it really easy to adapt your code that you write that's reusable with the reusable code that's in STL. So this is a very simple example, but it's also a good example of the power of STL and the whole theory of, write less, do more. And it also demonstrates the concept of zero overhead abstraction, because there's not a virtual method to be found in here. Lots of inlining. The compiler can optimize the heck out of this, and it's just going to work really well and is very clean and neat and easy to understand once you understand the patterns of STL. Okay, well, thank you guys for coming. If you enjoyed this content, please don't forget to like, and if you're new to the channel, please go ahead and hit the subscribe button. So thanks very much, and I will look forward to talking to you again soon.